Okay, so the stuff we're doing today, we are picking up with the second half of 4.3, a little bit more factoring. So I know that we've seen factoring a lot, and I know that factoring is something that we never ever really like to do. So I've got this nice little process that we can walk you through, and I'm sure some of you guys have seen this before. So I want you to write down these 4 steps, and I'm gonna walk you through this first example as we're writing down the steps. So hopefully this will help. And if you look, the difference between A and B is huge from C and D. A and B don't have anything in front of the x squared. Those ones are always going to be a little easier. And then C and D do have something in front of the x squared. Those ones are going to be trickier. But this 4-step process that I'm going to walk you through works every single time. All right? Not like some of these crazy factoring patterns that we try out. So the first step, let me write down, actually, I was going to say I was going to write down standard form, but there it is. So here's standard form, ax squared plus bx plus c. Remember when we're talking about a, b, and c, we're talking about the coefficients in front of the x squared and the x, and then the constant on the other side here. So first step is we are going to multiply a times c. So again, a is the coefficient in front of the x squared, and then c is the constant at the end. The first step is we're going to multiply those values. So like I said, I'm going to go down here, and I'm going to work through example a as we're going. So there's always technically, whenever you see just an x squared like that, the a is 1. So step 1 is we're going to multiply 1 times 30, and of course, anything times 1 is just itself. So that's the first step. The first step is usually pretty easy. Second step, and this is the part that's going to be the tricky part, but it's not so bad with A and B. So then find 2 values. So find 2 values. We're going to call them M and P. So find 2 values, M and P, such that, now here's the part that's a little tricky. Their product means multiplication. Their product equals A times C. And their sum equals B. Okay, so now here's the part that's going to take a little practice while we're working through. So we want to find 2 values, M and P. So we want the product to equal AC. So the first step that we take, A times C is 30. So what we want to do is we want to figure out what kind of things could multiply to equal 30. So step 2, we're going to list out, anything that could multiply and give us 30. So it could be 1 times 30. Could be -1 times -30. That's a possibility as well, because a negative times a negative always equals a positive. It could be 2 times 15, or it could be -2 times -15. Could be 3 times 10, or it could be -3 times -10. Or there's one more. It could be 5 times 6, or it could be -5 times -6. So that's the first thing we're going to do, is we're going to figure out all of the things that could multiply to give us this number that we found in step 1. So these are all of the different pairings that could multiply to give me 30. If I multiply any of them out. So now the second part, the more important part, is that their sum equals B. So here, B is -11. So if I add these 2 together, I do not get -11. All right, so let's kind of make a list here. So if I add these 2 together, I do not get -11. If I add these 2 together, I get -31, not -11. These 2, I get 17. These 2, I get -17. These 2, I get 13. These 2, -13. These 2, I get 11. Close. But I need a -11, so hopefully, here we go. -5 and -6, I add them together and I get -11. So let me kind of re-explain exactly what this step just did. So we want to find 2 values, M and P. So the values that we found were -5 and -6, such that their product is A times C. So when I multiply them together, I get 30, and their sum equals B. So when I add them together, I get negative 11. So the two numbers that I'm looking for, I always say that they have two jobs to do. Their first job is to multiply to 30, and their second job is to add to negative 11. So there are only two pairs of numbers in the whole world that do that. Negative 5 and negative 6 is the one that works for both. There are lots of different numbers that multiply to 30, pairs anyways. There are lots of different pairs of numbers that multiply to 30, and there are tons, infinite number of pairs of numbers that add to a negative 11. But there's only one pair that does both. Multiplies to 30 and adds to a negative 11. So that's step 2. Step 3 is that we rewrite the middle term. So now we're going to replace the bx with m and p, those values that I just found. So now here's why I know that this is okay. M and p, I know that they add together to get b. So this is really the same. So step 3, x squared. So this is, let me compare something really quickly. What we did on the last set of notes, I guess I'm going to have to flip a little farther, the foiling method. See right here how we get to this point and we combine like terms to get here. What we're about to do right now, it's kind of like uncombining like terms. So instead of just having one x value in the middle, I'm going to split it up and I'm going to have two x values in the middle. And that will help me factor. Because foiling goes from this step to this step to this step. Factoring goes from this step to this step to this step. So what I'm doing right now is getting myself from this step to this step. And then of course I'm going to go a step further to this step. So that's what I'm working on right now. So I'm kind of going to uncombine like terms in the middle. Okay, so I know if I recombined like terms, I would have negative 11, but that would be counterproductive. I'm trying to spread it out so that I can work on my factoring. And then the last step is to factor by grouping. Factor by grouping. So the way that factoring by grouping works is I take these two, I group them 2 and 2, just like this. All right, so I group the terms together, and then what I do is I factor out the GCF from each one of these terms. So if I'm looking at this term, I'm going to factor out an x, because that's the GCF between these two terms. So I factor out an x, and then inside I'm going to write what I get. So when I factor out an x from x squared, I'm left with an x. When I factor out an x from the 5x, I'm left with a 5. So now I'm going to do the same thing with this next group. The next thing I'm going to take out between negative 6x and positive 30, I'm going to take out a negative 6, and I'll explain why in a minute. First of all, because there's a negative attached to this, so I'd like to get rid of that. And I'm going to write my leftovers in parentheses again. So when I take negative 6x and I divide out a negative 6, what I'm left with is an x. And then when I take positive 30 and divide by negative 6, I am left with a negative 5. Okay, so I have one more step to factoring by grouping. And so what I'm going to do is I see these, I put them in green, and you can't really tell that they're green, but the x minus 5s are the same. So what I'm going to do, think of this as one term, think of this as one term. I'm going to factor out the common factor of x minus 5. So I factor that out, and once that's gone, my second term is what's left. So once the x minus 5 is gone, my second term is x minus 6. Okay, so that's my factorization. Now I'm sure some of you guys probably did this in your head, because like I told you, it's a lot easier when this is just an x squared. But we're going to need to use this process for parts like C and D, so we're going to practice it now. All right, so the last thing we do is what we were doing on the previous page. We take each of those pieces and we set them equal to 0. So we take x minus 5 and we set it equal to 0. We take x minus 6 and we set it equal to 0. So when I add 5 to both sides, I get x equals 5 as one of my answers. And then here I get x equals 6 as my second answer. So I've got two answers for my quadratic equation for part A. Okay, part B, I'm going to do the exact same thing. I'm going to walk through this process. So step 1 is I multiply A times C. Remember, A is technically 1, so 1 times negative 21 gives me a negative 21. Step 2, I am going to look for all of the possible things that could multiply to give me a negative 21. So let's start with, I just wrote it down, 1 and negative 21 could be negative 1 and positive 21. 2 is not a multiple, 3 is, so it could be 3 and negative 7. It could be negative 3 and positive 7. And I think that's actually it. 21 doesn't have nearly as many factors as 30 does. Yeah, because 4, 5, 6, none of those are divisors of 21. So this is it. So now what we're trying to do, like we look through up here, we're trying to find these two values. They multiply to 21, negative 21. We already know that for sure. But now we want them to add to this value right here, the negative 4. So let's start adding them. When I add these two, I get a negative 20, not negative 4. When I add these two, I get a negative 4. So that seems good. Let's just eliminate the other ones just to double check. Negative 1 and positive 21 is 20. That's out. And then negative 3 and positive 7 is a positive 4. So we're good with this one. So that is the one that we end up using. So we've completed step 2. We found these two values that multiply to a negative 21 and add to a negative 4. So in step 3, we're going to expand that middle term. So x squared, I'm going to put plus 3x minus 7x using these two numbers, and then minus 21 equals 0. And then I factor by grouping, which is exactly what I did up above. So the factoring by grouping will get pretty easy. We'll get used to it. So right here, right here. So we factor out a GCF. So if I look at this first grouping, they both have an x in common. So I'm going to factor out the x. I'm going to use a brighter color this time. So when I factor out the x, I'm left with an x plus 3. Oh yeah, that shows up way better. All right, in the next group, I have a negative 7x and a negative 21. I'm going to factor out a negative 7. And if you're wondering, should I take out a negative? Should I take out a positive? Keep in mind that we want these two things to match, and the only way that these two things will match is if I take out a negative 7, not a positive 7. So when I divide out a negative 7, negative 7x divided by negative 7 leaves me with an x, and then negative 21 divided by negative 7 leaves me with a positive 3. So that's exactly what I was looking for. I wanted these two to match. So just like above, think of these two as two different terms. I want to factor out the common factor. They both have an x plus 3, so I'm going to factor it out. When I factor out the x plus 3, what I have left is an x minus 7. Okay, so then finally I use the zero product property to set each one of these equal to 0. Okay, so I get x equals negative 3 as my first answer, and I get x equals 7 as my second answer. Okay, so now we get to the interesting ones. C and D, when I have something in front, it makes it a lot trickier. So I'm going to walk through these same steps. This is why I did these 4 steps with you in these previous problems. Even though I'm sure you probably could have just looked at this and factored it, I wanted to make sure that we were comfortable with this process. So step 1 is I multiply A times C. So 15 times 1, of course, is 15. Step 2, I'm going to come up with all of the possible products of 15. So now let's make this a little bit easier on ourselves, and I know you guys will probably start to recognize some patterns, and you can use those patterns once you see them. Here, like this one for instance, I wanted to multiply to a positive 30, but I knew that I needed to add to a negative 11. So none of these positive products are going to work for us. Really only the negative products are even an option. So here, I'm trying to multiply to a positive 15. I want to add to a negative 8. So if I want to multiply to something positive and add to something negative, I know for sure that these have to be two negatives. So let's make a little note here. So these have to be two negative numbers. Definitely need to be two negative numbers. That's the only way to multiply to something positive and add to something negative. So it could be a negative 1 and a negative 15. That's an option. Let's see, 2 is not a factor, 3 is a factor. So it could be a negative 3 and a negative 5. 4 is not a factor, and we've got 5. So that's it. Those are all the factors of 15. Keep in mind, we could include 1 and 15 and 3 and 5, but we know it's not going to add to a negative 8. So we can kind of eliminate those from the get-go. So negative 1 and negative 15, those add to a negative 16, so they're out. And then negative 3 and a negative 5, those add to negative 8. So I use these ones. My next step, just like my next step up above, is to use these two terms to expand my middle term. So I keep the 15x squared just the way it is, and then I kind of uncombine like terms with the negative 8x. So I'm going to write minus 3x minus 5x plus 1 equals 0. So I'm just using these two to expand that middle term. And I know if I recombined them, I'd get a negative 8, negative 8x, but that would be kind of going against what I'm trying to do here. So then finally, I factor by grouping. So I group these guys up. So between these two, a 15x squared and a 3x, my GCF would be a 3x. So I factor out a 3x, and then in parentheses, I want to write my leftovers. So when I factor out a 3x, 15x squared, divide out 3x, I'm left with a 5x. Negative 3x, divide out 3x, and I'm left with a negative 1. Next, between a negative 5x and a positive 1, remember I want the insides to match, so I'm actually going to factor out a negative 1. So when I factor out a negative 1, negative 5x, if I divide out negative 1, I'm left with a positive 5x. And then positive 1, divide out negative 1, I'm left with a negative 1. So just like before, my first term is going to be that term that I have in common, the 5x minus 1, and then once I factor that out, my second term is a 3x minus 1. Okay, so I'm going to set both of these equal to 0. So I set 5x minus 1 equal to 0, or 3x minus 1 equal to 0. These ones are going to be two-step equations. Add 1 to both sides. Okay, same thing here. Add 1 to both sides. Okay, so I'm going to get some lovely fractions here. So x equals, I get 1/5, and I get 1/3. Those are my two answers. Nice teeny tiny little fractions. All right, so another one of these. Same thing, these are definitely going to be complicated when I am working on multiplying bigger numbers on the outside here. So negative 12 times a positive 15, that's the first thing I'm doing. I multiply a times c. Might want a calculator for that. Let's see. Negative 12 times 15. I get negative 180. Okay, so this one's going to be fun. I'm glad we've got a little bit of space here. All right, so negative 180. Let's start working through some of these factors. So it could be a negative 1 and a positive 180, or a positive 1 and a negative 180, thinking it's probably not. Because remember, we want to add to get a positive 8. So let's start working through. So 180, let's see, 2 is also a factor. So it could be 2 and it would be negative 90. That would multiply to negative 180. Or it could be negative 2 and positive 90. 3 is also a factor. So 3 and 60. So it could be negative 3 and positive 60, or positive 3 and negative 60. Let's see if 4 is a factor. And you can always check. This is like a very easy thing to do to check if something's a factor. You could take 180. Oh, come on, calculator. There we go. You could take 180 and divide it by 4 to see if 4 is a factor. And it is. So it would be 4 times 45. So we could do negative 4 and positive 45, or positive 4 and negative 45. Let's see if 5 is a factor. So we do negative 180 divided by 5. So 5 and 36. Negative 5 and positive 36, positive 5 and negative 36. Let's see if 6 is a factor. Yep, 6 and 30. We might run out of space here, my goodness. So 1 positive, 1 negative. Let's keep checking. So 180 divided by 7. No, so 7 is not a factor. Let's try 8. Here, we're kind of running out of options here, which is a good thing. 180 divided by 9. Yes, 9 and 20. So negative 9 and positive 20, or positive 9 and negative 20. Let's Keep checking. 180, how about 10? That's definitely. So 10 and 18. So negative 10 and positive 18. Positive 10 and negative 18. Let's keep going. 180 divided by 11. Whoops, I can't see the screen. Come on, adjust. There we go. It's not divisible by 11. How about 12? 12 and 15. Okay, can we sneak one more in here? Negative 12, positive 15, positive 12, and negative 15. So let's check 13 and 14, but I think we've got them all. 180 divided by 13. Nope. 180 divided by 14. Nope. And then we're back at 15, which we already have. So we've got them all. So what step 2 says is we're trying to get their sum to equal 8. So some of the big ones, like these don't equal 8. These ones are ridiculous. So you can kind of look through. At this point, once you've got your whole list in front of you, and you might have just been able to look at the negative 180 and figure it out, but the ones that add to a positive 8 is this one right here. The negative 10 and the positive 18. Those add up to positive 8. So let's take our step 3, rewrite the middle term, and then we can factor by grouping. So negative 12x squared minus 10x plus 18x plus 15 equals 0. Okay, so step 4, I guess I really haven't been writing the 4, but really the next step is kind of the step 4, I guess. Factor by grouping like this. So with these two, common between a negative 12x and a negative 10x, between a negative 12 and a negative 10, I have a negative 2 in common, and then I can also factor out a copy of x. So in parentheses, I want to write my leftovers. So if I take negative 12x squared and divide out a negative 2x, I'm left with a 6x. And if I take a negative 10x and divide out a negative 2x, I'm left with 5. Okay, next one, 18x and 15. The only thing in common between those two is a 3. Okay, and let's write our leftovers in parentheses. When I divide out a 3 from both of these, I'm left with a 6x plus 5. Okay, so last step to this factoring. Remember, this is a term, this is a term. I'm going to factor out the 6x plus 5. And once that's gone, what I have left is a negative 2x plus 3. Okay, last thing, zero products property. I'm going to set those two factors equal to 0. And then solve for x. So these are two-step equations now. Okay, and 2 steps over here. Don't forget about the negative 2 in front of the x. Okay, so this one gives me a positive 3/2, because that'll reduce down. And then this one gives me a negative 5/6. So 2 answers there. Now usually, the uglier these numbers are, the more likely you are to end up with weird fractions. Okay, let's see what else. You know what? I think I'm going to cut the story problem again. I think you guys will probably be okay with that. We're already at 23 minutes. All right, again, good luck, work hard.